All right, so we are in 6.4, 6.5, day 2, which is bringing us to the end with squares. So squares are parallelograms, which means that they're also quadrilaterals. They're going to have all the qualities that your quadrilateral has, which is 4 sides and a sum of 360 degrees. All of your properties that parallelograms had, which were opposite angles were congruent, opposite sides are congruent, diagonals bisect each other, supplementary, consecutive angles, lots of things. But that then filtered down to squares and rhombi. Well, rectangles and rhombi. A square is going to contain all of the properties of the parallelogram, the rhombi, and the rectangles. So it's got this like powerhouse of all of these properties. So the one that keeps squares different from rectangles and rhombi is that it has 4 congruent angles. That's 90 degrees. 90 degrees. Which, yes, rectangles have, but what rectangles don't have that the rhombi have is 4 congruent sides. So it's this like merging of a rectangle and a rhombus. So you have all this cool stuff. So your angles are all 90 degrees, all your sides are congruent. You still have diagonals, and those diagonals are going to bisect each other. But there's also some other additional stuff. So when we had the rhombus, when we talked about the diagonals did something special. The diagonals created right angles. They happened at a perpendicular. And so that is true for the squares as well. So you have right angles at the diagonals. This one's really ugly. That's better. So you have right angles at the diagonal crossing point, which if you take into account, it's also bisecting. The diagonals also bisect the angles. So those are being cut in half. This whole thing creates 45, 45, 90 triangles. So you have 4, 45, 44, 45, 45, 90 triangles inside of a square, which we kind of already talked about back when we started trig and special right triangles. So let's take a look at a few examples. We have a square here with a piece of a diagonal that is 7. So we're saying this piece right here is 7. That is it. And it says to find the length of one side or each side. Since they're congruent, the length of one side is the length of all the sides. So because these are congruent, you can also say this is 7 if you'd like. Or you can also take into account that this is a 45, 45, 90 triangle. And that 7 is happening across from a 45 angle. So we have 45, 45, 90, which is S root 2. I told you this stuff is not going away, guys. We will be using this till the end of the year. So across from the S is a 7. What I'm looking for is the side that's across from the 90, which is going to be your S root 2. So that means 7 root 2 is the S root 2, which is one of the sides. So the side of my square is 7 root 2. Let's see here at example 2. It says square fish, Fish, has a length for IT at 6, and I wants me to find IH and IS. So these are congruent here. So that means IH is going to be a grand total of 12. And then IS, so one thing you can think about is that you create a triangle here. And this is also a 45, 45, 90 triangle. Your hypotenuse, we just discovered is 12. So you have 45, 45, 90, s root 2. So we are looking for one of the sides across from the 45. So that's our s. Across from your 90 is s root 2. And so if we divide s root 2 by root 2 and 12 by root 2, so we'll eliminate the root 2's on that side. We're going to multiply this side by root 2 and root 2. Oops, that didn't look like a 2. And that gives us s is going to be equal to 12 root 2 over 2, which simplifies to 6 root 2. So is s root 2. Now we have SQUR square, which is a square. And they're asking us to find the length of AR and RQ. So AR is just this length right here. And then RQ is the full length, which we know these are congruent. So I have a triangle here. Here's my right angle, and then these angles are 45 and 45. And I'm trying to find one of the 45s from this side. So I'm going to put S here. So that gives me 45, 45, 90, S root 2. And there are a couple of ways you can set this up. I could do the larger 45, 45, 90 triangle. That works too. And 4 is across from the 90, which is S root 2. So S root 2 equals 4. Go through and divide your root 2, and then multiply your root 2. These are going to cancel out. You get S equals 4 root 2 over 2, which just simplifies to 2 root 2. So 2 root 2 is our S. So that tells me that AR is 2 root 2. And then if I double that for the length of QR, that gives me 4 root 2.